Question. Hey, by the way, the last 2 days, this screen was not up. So I've been collecting homeworks. Like today's what, Friday? So like I was collecting for the last 2 assignments, and I only got like a third of y'all's homework. I don't know if y'all missed that. So even though I don't want last night's, if you have that assignment from Wednesday night or Thursday night, it was page the 577 one, and then the 582-83 one. No. Yes. Yeah, the 582-83 one. Literally yesterday, 5 of you gave it to me. And the day before that, maybe 10 out of 18. So it's been slim. So if you have it, please give it to me. I'll check you off and get that in there. All right. Anybody got a question on anything on law of signs? My guess is you probably didn't have too much trouble because you hadn't had any ambiguous case stuff in there. But today, I'm going to start throwing the ambiguous case. And the ambiguous case is what I've been referring to. And specifically, do y'all know what ambiguous means?
Nefarious.
It feels nefarious, but it's more just vague. But we don't need to be vague about it. Like there should be no ambiguity at all when you're doing this, because there's one situation that when you look at it, at face value, you go, huh, that, if I'm solving for that angle, y'all with me? If I'm solving for that angle, it could be obtuse, okay? And then just avoid it like the plague if you can. So if you ever find yourself, hear this, if you ever find yourself using law of sines to find an angle, and at some point to find that, not a side, who cares about sides? Finding sides is not a big deal. Finding angles, because to find an angle, when you plug that, when you have that theta or that alpha in there, that A in there, you're going to have to inverse sine, right? And when you inverse sine, if that angle could be or is obtuse, calculator's going to lie. Okay? That's what law of sines does. It's a nasty cat. Okay? So you can avoid that. A lot of times we've been talking about that. But the bottom line is this. When you're dealing with this case, SSA, okay, and you see some given information like A is 5, B is 6, angle A is 32. What does that tell you about B? What do you know for certain? It's bigger than 32 because B is bigger than A. And bigger than 32 could be anywhere from 33 to 180, right? Well, technically not 180 because we've already got 32 accounted for. Anything from 32.1 all the way through 148, right? Ish. So if that's the case, it could be obtuse. Oof. Then that's an ambiguous situation. That is the ambiguous case of SSA that we are talking about. Everything else is not a big deal. How about this? I haven't mentioned one like this before. How about A is 5, B is 6, angle A is 93 degrees. Tell me, solve the triangle. Talk to me. Don't be afraid. Why didn't it not exist? Why doesn't it exist?
Because B has to be bigger, and you can't have bigger than 90 at that point. Bigger than like.
Yeah, y'all see that? I've already got one of twos. Can't have two, or I'd be over 90. There's only 87 degrees left for these last two angles. This says B is 6. That's bigger than A. That means angle B is bigger than angle A. It's impossible. D and E. Do you know what? Do you know what happens sometimes when you type this in your calculator? It spits out an answer. And you're like, what? How could it do that? It doesn't know it's a triangle. It's not like you go, hey, Mr. Inspire, I'm doing a triangle here. So it doesn't know, it's just doing the math. I have, of course, have a collection of those problems. Now I'm hoping that literally on your page, you write, triangle does not exist, and nothing else. But every now and then, if you were to plug this into the law of sines, it spits out an answer. It's not going to make any sense, but it spits out an answer. And you're going to feel really good about it. And guess what? A lot of times when it does spit out the answer, it spit like a lot, like for instance, let's just say I gave you A equals 137, and I say find angle B. It'll spit out something like 53 degrees. And you'll be so happy you got it. You're like, you're just plugging around, crunching the numbers, not really thinking about what you're doing. But what just happened here? Is that even possible? No, I'm already over 180. Now, unfortunately, I won't ask you for angle C. If I'd asked you for angle C, you would have caught that error, wouldn't you? But I tell you, I do this all the time. People, I just give them that. They write, they figure it out. They don't think. They just plug. They get 52, they write it down, they move on. And I'm just like, oh. But you got to pay attention. Hopefully on stuff like that, you just write D and E and call it day. You with me? But on this one, what happens? So let me draw a picture of this. I haven't done this yet. I'm going to draw a picture of this situation as good as I can. In fact, I'm going to change these numbers a little bit. How about A? We'll make it, we'll leave it 32. But let's let B equal, 10. No, we'll let B equal 12 and A equal 16. Okay? There's a method to why I'm doing this. No. Sorry. A equals 12. B equals 16. So let me give you a picture of this. All right? Based on this, I have an angle that's roughly 30 degrees. I think you guys kind of have an idea about what 30 degrees looks like. Looks kind of like, if that's 90, and I break it into like 3 parts, it's kind of like 30, right? Ballpark. Now, because it's an angle, I'm just going to do this. I'm going to say it's 30. It's heading in that direction, but I really don't know how long these edges are. So I'm just going to do this. But that's my angle A. That's 32 degrees. Right now, I got to tack these 2 sides on there. So where would side A be? Opposite of that. I can't really put that in there right now, can I? Because I don't really know where to connect it. Where would side B be located? On either one of those sides, because I don't know where angle B is. So why don't we just put it on the bottom just for fun? And I'm going to make it 16, and 16 is going to be exactly 4 pens. Okay? So we're going to make 16 that length. So I'm going to come over here. I'm going to draw this length right to there. So that is side B. Okay? And again, I have no idea where this ends. It's just pointed in that direction. Are you with me? Yes, no? Okay, now I can mark A, because you told me A was over on this opposite side, but now I have something to hitch it to, don't I? You with me? And if B is 4 pens, which is like 4, 4, 4, 4, then A would be 3 pens. So I'm going to take this, and I'm going to mark it right there. Now, you can clearly see that this is my triangle, right? There's only one problem. Couldn't I also mark A there? Couldn't I? So what happened? What does that mean about this information? There's 2 triangles. Whenever I see a problem like this, where I am looking at finding angle B, and I'm looking at it and I'm going, wait a minute, it could be obtuse. Maybe. Right? What that means is it is obtuse, but it's also acute. It's both. Your angle B right here is going to be this angle, right, opposite B, but also this angle opposite. These are both your angle B's. This is the one your calculator is going to give you. This is the other one. But your calculator can only spit out a cube, right? So it's going to spit out that one in the corner. And then you're going to have to figure out how to find the other one. You kind of already know, but you might not realize you know. But look what happens if you don't pay attention. If you don't pay attention, you're going to go sine of 32 over 12 equals sine of 16 over b. You're going to cross multiply or use your slide rule. You cross multiply and divide or use your slide rule, you get this, right? You go and you type this in your calculator. So fraction button. And by the way, if you're getting one of these inspires and you want to ask me questions, don't feel bad about jumping in and saying, where's the fraction button or whatever. Sine 32, make sure you're in degrees, which I am not. Document settings, degree. And I get 6.24. Does it feel right? But I am in degrees. I'm going with it. That really doesn't feel right. Oh well. 6.24 degrees. Okay? Now, that's B1. If B1 is 6.24, now think about this. You see this triangle right here? That's not the triangle we're looking for because that doesn't even include A, does it? But it is in fact a triangle. It has nothing to do with my two triangles, but it does. It is an isosceles triangle, isn't it? So if that's 12 and that's 12, if that's B1, what is this part? Also B1? And if that's B1, what is that? 180 minus B1. Now that sounds familiar. 180, does that make sense again? If this is B1, then that's B1 because this is isosceles. And if that's B1, this has got to add to 180. So B2 is 180 minus B1. So the second I get B1, I can come over here and say, well, B2 must be 180 minus that, which ends up being 173.76. This is not right. Why am I? Something's going on here. It smelled bad from the start. Hold on. 12 sine 16 over sine of 32. I am in degree mode. Why is this?
I got the same as you. I got 6.64.
Yeah. Do you see why B is bigger than this? Oh my gosh.
B2 is bigger.
It's not sine of 16 over B. Did nobody see that? Oh, I'm so sorry. It's sine of B over 16. I knew that didn't feel right. Anyway, let's try that again. Sorry. You be careful. I didn't even do an inverse sine, right? Solving for B. Sine of 32 over 12, right? Plug that in your calculator. 16. Come on, calculator. 16 sine of 32 divided by 12 gives me 0.707. Rounded to 3 decimal places, whatever. But again, this is just rounded. And then now when I inverse sine, the answer, that's better. I get angle B is 44.9, we'll call it 0.96 degrees. So that's your B1. Okay, so if B1 is 44.96, then that means this thing is 44.96, which means angle B2 would be what?
180.
Minus 44.96, and that ends up being 135.04. And the reason why I knew for a fact that there was no way that I knew there was a second angle But this has to add to that and still have room for the last angle. And the way I did it before, it didn't have room for the last angle. So what this means is if I give you a problem that's one of these weird ambiguous things, you're going to have two triangles almost all the time, or you're going to have no triangles. Now, when I say no triangles, what that means is, what if this side, by the way, I'll finish this one up, but what if this side was like just 4? If side A is just 4, remember each pen is like 4, and when I put 4 in there, what happens? It doesn't make it there, does it? So your calculator, guess what it's going to say? Error. Awesome. If it says error, maybe double check your math, make sure you typed it in right. But if it says error, you go, oh, well, there must not be any triangle there. Okay? So it's either going to say error or it's going to give you an answer. But if it gives you an answer, it really means what? There are 2. And how do you find those 2? The angle and 180 minus the angle. If you really think about it, isn't this what we did about 4 or 5 days ago when I gave you this problem? Solve. Sine of theta is 0.707. Didn't you write the theta down and inverse sine this? And we did that to find the reference angle. Do you remember? And you did it, and you found out that the reference angle was 44.96 degrees. Then what did you do with it? You said what? Well, the unit circle only works for really nice, pretty answers, like 1/2, square root of 3 over 2. I would say sine is positive where? First and second quadrants. So I would mark my reference angle there, and I would use that one, 44.96. But how would I find this one? Subtract it from 180. I'm doing the same thing I've been doing. But I don't really have to think about it as much, but I'm doing the same thing. And by the way, if it's not an ambiguous case, guess what happens every time with this second angle? You could still do it this way. You could say, okay, theta 1 is 44.96 plus 360n. Theta 2 is 180 minus that, so 135.04. You could still find these every single time. But if it's not one of these ambiguous case situations that I've been doing, where it's possible that it's obtuse, guess what happens with this last angle? Anybody got a guess? It exists, because there's always going to be one in the first and second, right? But guess what happens? It's so big that what? When you add it to this, it's over 180. I had somebody once who said, well, couldn't I just do every problem like that and completely forget about the ambiguous case? Yes. Just a lot of extra work. I'd rather take an eyeball. I'd rather just eyeball it and go, oh, crap, B is obtuse. Okay, it's one of those that's going to have 2 triangles if my calculator gives me an answer. If my calculator gives me error, it's done. None of these. I would rather think that way. But technically, you could take any SSA, plug in your law of sines, get down to here, right there, and solve it like you did on that page where we were just solving the trig functions. Take your first answer, it's in the first quadrant. Take it, subtract it from A, take the second quadrant, and then just look at it. And if that, again, this is like angle A or angle B. If B and A don't give me 180 yet, great, there's room for C. If that B and A don't add up to over 180, there's room for another C. But most of the time, that second B, when you add to this, is greater than 180. So you go, no second triangle. You tracking with me? But in this case, they both could add to this and give you room. So let's just finish solving. You'll probably have one like this on your test. So at this point, I really got 2 separate triangles. So let's treat them totally different. How would I find the C that goes with this B and this A? 180 minus A and B. So I would go 180 minus the 32 minus the 44.96. How do I find the C that goes with this one? Does it have anything to do with that? No. I'm just going to do the same thing, but what? Minus that A, but this time minus this B. You with me? And then finally, how do I find the last side C? Well, at this point, I have everything but C. Are you going to ever get in trouble finding a side? No. There's no inverse sine involved with finding sides. So can I use anything I want? Just plug in the law of sines, plug in the law of cosines. But remember, this C only goes with this information, the B1 stuff in the original. This C only goes with this information, the C2, B2 in the original. The original stuff goes with both.
Wait, to find a side, do you have to use law of sines or law of cosines? Can't you just do like sine or like cosine?
No, because it's not a right triangle. Remember, all the trig functions, the 6 trig functions, are all based on right triangles. We created law of SOAPs. Remember the proof that I did on law of, we created those actually using a right triangle. Remember when I drew down the H? I drew down that height and created a right triangle out of them so that I could manipulate my formula and create a new formula that allowed me to mess with them. But I can never go back to sines and cosines and tangents unless I know with certainty there's a 90-degree angle in there. And guys, there's never going to be a 90-degree angle in the work that we do. Mainly because I give you these whole number values. The only way to get a 90-degree angle in there is to give you stuff like root 2s and root 3s, things that would give you like 90-degree values or 3, 4, 5s or stuff like that. And I'm not going to do that. Is this making sense? Now, let me ask you a question. Raise your hand if I gave you side, side, side. Do y'all know which thing you have to use first? Which formulas would you have to use first to begin the process? Raise your hand if you know that. If I give you side, side, side. Okay, hear this. Side, side, side. Also side, angle, side. Same situation. What are you going to use? Law of cosines. Okay, so hypothetically, for those of you that would use law of cosines first, would you, if you use law of cosines first, would you stick with law of cosines for the duration? Or would you, after using law of cosines, switch over to law of sines because it might be a little simpler? Switch over. Now, if you're going to stick with law of cosines, it doesn't really matter what I'm about to say. But if you're about to switch, if I'm about to switch, if I start with side, 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 how many triangles can there be? Just one. The only time I can ever get 2 is in this special ambiguous situation. So any other situation, there can only be one triangle, right? Is it possible that if you start with SSS, though, that you could find yourself solving for the biggest angle using law of sines? And if so, do you think the calculator is just going to be nice to you because you made a careless error? So how can you, for those of you that are going to use law of cosines and then switch back over, what could you do when you're using law of cosines to alleviate the trouble that you could potentially get in?
Solve for the angle across the shortest leg.
Across the what?
The shortest leg.
Biggest leg. You're going to find the biggest one, right? Because
first, that's not law of sines.
yeah, well, okay.
Yeah,
yeah. So if I'm using law of cosines, why not just find on the side, side, side? Why not find the biggest angle? Because you got a choice, right? Now here's the thing: you might go, well, what if I don't have a choice? You have a choice. What if I said A is 10, B is 12, C is 20? Clearly, side C is the biggest side, right? And that means angle C is the biggest. And again, I think I mentioned this before. This is what I'd probably do on a test. Sorry, I'd say solve for angle A and then angle C. I mean, it's compelling. I do it every year. And people walk up there and they go, oh, I need angle A first. I got to use law of cosines. So they walk over here and they go, A first, A squared equals 20 squared plus 12 squared minus 2 times 20 times 12 times cosine of the A. And they finally solve for angle A and they get this angle. Now, if you're going to stick with law of cosines, great. Because it's not going to lie. You could do the exact same thing with law of cosines, find your angle C, you'd be done. But if you switch over law of sines, now what are you doing? You end up doing what? Using law of sines to find the what? Biggest angle. If that angle happens to be obtuse, your calculator is going to lie to you. So what could I have done here, right there, before I even began to avoid that ever happening? just find C first, right? So to find C first, I just do that. And now what is completely off the table? Getting lied to. Because angle C, the biggest angle, is found. Now, what if you do what I just did by mistake, and you do find angle A first? And you're like, man, I totally forgot. But I already have this angle A, right? Is there some law that says you have to find angle C? I mean, what could you still do at this point if you wanted to go to law of sines? Find angle B and subtract from 180, right? Yeah, you could still do law of sines, but just find angle B. That's not like you're going to prison if you find an extra angle, right? So just do that. Then you have two angles subtracted from 180. Or stick with law of cosine. I'm mentioning all these things. Your test is not going to be like completely riddled with a bunch of stuff that's every single time ambiguous. But there are going to be 2 or 3 times where I'm checking what you know. And sometimes I grade them pretty hard. Like if you forget this second B, or forget the other half of the triangle, I give you like a dot's worth for actually solving, but you're going to get slash dotted. So you're losing most of the work, even though you actually found one of the angles right here, one of the triangles, because you missed seeing that there were 2. That was the main focus of this. I probably should exit, but I give you a little mercy, right? Or right here, if you do find A, and then you go use law of sines to find angle C, whatever, now that you found A, right, you pull A down, pull it in there. If you do that, guess what kind of C you're going to get here? A lovely what? What am I going to get when I solve for C? I'm going to get something. What's it going to be? What kind of angle is it going to be? It's going to give me an acute angle, which if you're lucky, it would be acute. But guess what? I'm going to engineer the question, so it won't be, right? It'll be like a 98-degree angle, and your calculator spits out 82, and you're like, 82. And you write it down, right? Because you weren't paying attention. So again, be proactive or be defensive, whatever it is. Ask yourself, every time you plug something into the law of sines, ask yourself, am I finding the largest angle? And most of the time you can avoid it. Like right here, am I finding the largest angle? Crap, I am. Well, let me avoid it. Let me just find B. I can avoid it here, can't I? Just avoid it. Now, in an ambiguous situation like this, you can't avoid it. That's the only time you can't avoid it. And when you can't avoid it, guess what? Don't let it bother you. It just means whatever your calculator spits out, there's another triangle formed by its complement. I'm sorry, supplement. So write it down, write down the supplement, solve them both. Now, there is, if you read in the book, there is a way not to have 2 and not to have error, which means none, but to have 1. Anybody got a guess on how that would happen? How would I only have 1? No, it's possible, but it's not that. Think about it. If I get an answer, I have to subtract it from 180 to get its supplement, right? And I get 2 different angles. So if this spits out 90, then when I subtract 90, I still get 90. Well, that would be the same thing. Your calculator is not going to spit out 90 because, again, to spit out 90, it has to be a 90, a special triangle, or some like 3, 4, 5, or 1, 2, root 3. Those never happen with the ones I give you. So when I give you these situations, if I'm giving you whole numbers, like they would be irrational angles, like 32.17, or it'd be weird values. If I give you whole number values, you're never going to get 90. Now, you might get 89.3, but that's not 90. It'll always be different. You'll have 2 different or none whatsoever. And again, the none happens when your A is so small, like this. It just tries to get back. It's stretching, trying to get there, but it just can't make it. So there's none. Actually, it's not sad. It's happy because your work is significantly less. You just D&E it, right? Okay, let me throw you a couple. see what's up here. All right, check it out. What if A 15.4, B 12, C, okay, I don't want to do that one first. Sorry. What if C, angle C, 37, little c, 9.3, little b, 12, find angle B. What kind of situation do I have here given to you? What kind is it? The ambiguous case of side-side angle. So it's a side-side angle, right? Not because I have side-side angle in this order or whatever. It's not because of that. It's because if I were to go look at a triangle labeled ABC, ABC, these are opposite each other, and that's in between it. So you have a side connected to a side connected angle. And what's the obvious thing that shoots up to let you know that?
Two of the same.
Two of the same. If you have two letters that are the same, it's not side angle side. It would have to be side side in this case, right? So a blind person, the one that's not on their game, is just going to go sine 37 over 9.3 equals sine B over 12. They're going to slide the 12 up there. They're going to type that in their calculator. This happens every year to maybe half the people. Hopefully not this year to half. Maybe last year to half, though. And when I do that, it spits out 0.77654-ish. And then I'm going to inverse sine that answer. Trig inverse sine that answer. And it gives me 50 point, I'm just going to round to be tenths, 50.9 degrees. And they circle that, and they move on to the next question. And a few hours later, I do that to them. Why? Because right here, this B has to be bigger than what? That C, because the side's bigger. And if it's bigger than that, that means it's possible that it's what? And if it's possible that it's obtuse, that's the one time you cannot get away from it. You can't avoid B by solving for A. You have no choice but to solve for B, right? This is the situation. And it's the only one that really should give you issues. It's the only one that goes, well, that just means that's my first answer. I did get an answer, right? And now I got to go find the second. So what do I do to find the second? Subtract it from 180 because sine is positive in the first and the second quadrant. So when I subtract it from 180, I get the second one, 129.1. And on this one, I didn't say to do anything but find B. So those would be your two angle B values. Not too bad. What if I do this? 137 degrees. Now what? D and E. Why? If side B is bigger than C, then angle B has to be bigger than angle C, but that would give you two obtuses, which is impossible in a triangle. Want to see something weird though? Check this out. It might not work, but I think it does. I'm hoping it does. It does. I plug 137 in there, it gives me, and when I inverse sine that, guess what my calculator spits out? $61.6. Who's going to catch it? If you're not paying attention, my hope is that you look at this and go, wait a minute, that's impossible, D and E. But if you're not paying attention and you just take this and go, oh, side angle, let me plug it into the law of sines, let me just solve, and it gives you, spits out 61.6. you're not paying attention. You come over here and you write 61.6, right? But have you noticed something? It's already over 180. And even if I come over here and go 180 minus 61.6, what do you notice? Way above 180 now, right? So it just doesn't work. Throw them both out. But my hope is that you go, wait a minute, this does not exist. Angle B does not exist. And don't do any of this. But just know, sometimes your calculator will lie. And if you do all the work I've given you, and you do the review sheets, and you do all the practice problems, you'll see enough of these that kind of test you. And if you check your answers, I mean, if you don't check your answers, you're just going to be writing crap down. You won't know if you're right or wrong. But what time's this bell ring today? It's got to be close.
I only have a full period to do.
11:35, 4 minutes. No, we only have 40 minutes to do.
Oh, because we bumped up 10 minutes.
I think we have. Yeah, I think you have full periods in 6th and 7th. Well, yeah, 5th's always full because of lunch. 5th, 6th, 7th. You think you're with me? Okay. See what you can do. $11:35. You only have 3 minutes. Y'all feel okay about it?
So we're taking the test Friday?
Yeah, we're actually going to stick to your original assignment sheet. And we're just going to have our test Friday. Actually, it makes more sense. I really moved y'all's to Monday because it didn't make as much sense with my other classes, but it makes more sense with yours. And I'm hoping I don't go down for the count, man. Talked to a friend of mine last night. He's like, man, I sore them on both of them. That's it. It's like, oh.
It's weird how it affects people.
Yeah, this whole virus is like that, man.
It's no pattern too. Like it's not like different families have a different ways.
Yeah.
Yeah, my dad had it, and he was the only one. He had it in August, and then I found out in November that I had antibodies from when he had it in August.
But you showed nothing, but he
I
showed.
nothing, but he showed.
Yeah.
I'm the only one who's been tested for antibodies.
Huh. I had it in August, along with my daughter and my wife. My son didn't get it. He was around tons of people, never got it. You know, at Auburn, nobody's wearing masks around. And I mean, you saw early on that year. I mean, they do now because they can't go on campus, and there's the Auburn
Are we
little.
getting our mask laws taken off or something in April?
The school's
The mandate will be off, but I don't know. I'd be shocked if this school said not to wear them.
They're gonna wait till next
Yeah, who knows? But I would truly. I got an email today about, hey, we're looking for advice. Any thoughts you have on the matter? I mean, like, I don't know if you know this, but if you read our COVID thing, it says in level 2 that as long as you can socially distance, you don't need to wear a mask. That's what it says. And then in level 3, it just adds an extra nurse. So really, level 2, level 3, literally, our plan, Homewood plan says, if you're socially distanced, you don't have to wear a mask. But half this place would go. Parents would lose their freaking minds. Not all of them, because some of them hate the whole mask thing. Some of them are like crazy, like adherent to all of that. But there's so many people that would lose their mind, yank their kid up, put them in virtual, that I just don't think they're going to do that. Not with, April 9th, there's 6 weeks left?
Yeah, we'll just keep it.
What's the point of creating chaos for 6 weeks? I mean, even if in whenever that is, 4.5 weeks from now, they saw stats that said, oh, Texas and Mississippi and Iowa are still fine. Why create chaos? And I would be shocked if, hopefully next year, if they can keep you spread out, they'll give you an option. But
Take it off.
And hopefully a lot of people will.
yeah, and a lot of schools have done. I know a school in Montgomery Academy, that they can sit down and take it off.
Yeah.
And they haven't spread out. But I don't know. We'll see. Be nice to see y'all's faces, though.
Yeah.